welcome to the class. This is the first session of my class on YouTube about arithmetics. I'm doing a session based on arithmetic questions from previous CAT questions. So this is the first question, and I guess you realize that arithmetic is important because of the fact that it's one of the major areas of the exam. You will get the maximum number of questions from arithmetic in the exam, and the first question I'm showing you. So the first question I'm showing you here is this one. The question says that a tank is fitted with pipes, some filling it and the rest draining it. So all filling pipes fill the tank. This is the first question. Have a look at this. Let me just increase the font size for you. And this is the first question. I hope you can see this. So a tank is fitted with pipes, some filling it and the rest draining it. All filling pipes fill at the same rate, and all drain pipes drain at the same rate. So the question says that the empty tank gets completely filled in 6 hours when 6 filling and 5 draining pipes are on. But this time becomes 60 hours when 5 filling and 6 draining pipes are on. So in how many hours will the empty tank get completely filled? I'm just checking why this is not showing you your screen. So this is the question for you. Okay. So this is the first question for today. Let's have a look at this. And I hope you can see this. Is the question going now?
Yes, sir.
Okay, thanks. So I'll just continue. Thank you so much. So this is the first question for today. So the question says a tank is fitted with pipes, some filling it and the rest draining it. I'll just continue. All filling pipes fill at the same rate. and all draining pipes drain at the same rate. The empty tank gets completely filled in 6 hours when 6 filling and 5 draining pipes are on. But this time becomes 60 hours when 5 filling and 6 draining pipes are on. In how many hours will the empty tank get completely filled when 1 draining and 2 filling pipes are on? So let's gather the information that is given to us here. The information given to us here says that when you have 6 filling and 5 draining pipes on, let's say the filling pipe fills the tank in F hours and the draining pipe does, or let's say the filling pipe does F units of work per hour and the draining pipe does D units of draining per hour. So the net outcome per hour is 6F minus 5D. And the empty tank gets completely filled in 6 hours at this rate. So that means if you multiply this by 6, what's going to happen is that 36F minus 30D will be the amount of liquid to be inserted. What I've done here is I've used F as the filling point or the rate of filling and D as the rate of draining per pipe in, let's say, liters per hour. So the total liters to be filled will be the net sum of 36F minus 30D. Now instead of this, if I go with the other part of the question, which says the time becomes 60 hours when 5 filling and 6 draining pipes are on. So what this is telling us is that if you're filling 5 filling and 6 draining pipes, if you put these on, then the time for filling required is 60 hours. So in this situation, 300F minus 360D will again be the total liters to be filled. And since the same tank is getting filled in both cases, these two have to be equal. If you equate the two, you will get, you equate 36F minus 30D with 300F minus 360D. So what will happen now would be 36F minus 30D is equal to 300F minus 360D. And since the two are equated, you get 264F is equal to 330D. And that will get divided by 66 on both sides. That will give you 4F is equal to 5D, or F is equal to 1.25, 5 by 4 or 1.25D. This is the outcome you get here out of this scenario. Now the question goes on and says that in how many hours will the empty tank get completely filled when one draining and two filling pipes are on. So if you are so since F is equal to 1.25 D, you can think of the amount to be total amount to be filled in the tank from this equation or from the other from the right hand side from either one. You can just replace F with 1.25 D and minus 30 D. So what will happen is you will get 45 F, 45 D minus 30 D, which is 15 D. So this is the capacity where D is the number of liters being drained every hour. So this is the first point of this problem. Now the question goes on to tell us that if I'm filling using 2F, two filling pipes and one draining pipe, this is the same as filling using 2.5 draining pipes minus one draining pipe, which means my filling rate effectively is going to be equal to 1.5 D, and at that rate if I'm going to fill a total of 15 D, then it's going to take me 10 hours to do it, because I'll have to divide 15 D by 1.5 D. So my outcome comes out to be 10 hours. That's the correct solution to this question. And it is a straight question in that sense. Straight question in that sense that you had to do nothing but just react. And if you look at CAT-18, a lot of people talked about CAT-18 as a very tough exam. But इस question को देखो, and that's why I'm trying to pick. Especially the arithmetic is supposed to be one of the toughest areas of CAT-18. But if you have a look at this, you would realize that that this question is something. Of course, you know that this question comes from the time and work chapter. You call it time and work, or you call it time pipes and cisterns, whatever you call it. And this chapter or this question would belong to the first. I mean, if somebody has solved around 150 to 200 questions on, if somebody has solved around 150 to 200 questions on time and work, he or she should be able to solve this question. It's a standard question on time and work. It's got a standard process. There's no variation in this question, and hence the question mark does arise that why do people talk about CAT-18 being a tough exam? And I'm showing this in this course on YouTube. I'm showing this to you through the arithmetic questions, specifically because of the fact that the arithmetic questions were supposed to be the toughest of the CAT-18 areas. So this is our second question now, and I want you to look at this and first try to solve it on your own. And this is a question from time speed distance. So I hope you've read the question. And this question basically reads, it basically is reading that point P lies between points A and B such that the length of BP is thrice that of AP. So again, let me just pull out my paint window to represent this. I'll open a new size of window here so that I don't need to open it again and again. So this is the question here. Point P lies between point A and B, says that the length of BP is thrice that of AP. So let's represent that there. So there is a line AB. We have this line AB. And on this line, point P lies between A and B, says that BP is thrice that of AP. So I'll have to put P somewhere here so that if this is X, this is 3X. And car 1 starts from A and moves towards B. So we have car 1 starting from A and moving towards B. Simultaneously, car 2 starts from B and moves towards A. Car 2 starts from B and moves towards A. And car 2 reaches P 1 hour after car 1 reaches P. So, whatever time car 1 takes to reach P, let's say it's T hours, car 2 takes T plus 1 hour to reach there. This is what the question is telling us. Car 2 reaches point P 1 hour after car 1 reaches P. This is the meaning of that information. This information here has to be used in that form. That if car 1 takes T hours to go from A to P, car 2 will take T plus 1 hour to reach P. And then the question says that the speed of car 2 is half that of car 1. Now this is an important structure in the question because this is the last reaction, and once you get this reaction, most likely you're going to get the answer to this question. The speed of car 2 is half that of car 1. That means if the speed of car 1 is 2s, speed of car 2 is s. And then the question simply asks us the time in minutes taken by car 1 in reaching P from A is. What is the time in minutes taken by car 1? Now how do you do this question? So what is happening in this question, if you look at the equation for car 1 is x divided by 2s, distance divided by speed is time. And for car 2, it is 3x divided by s, which is t plus 1. Now, the question asked of us is what is the time in minutes taken by car 1 in reaching P from A? So we are looking at the time for this journey. The time for this journey is given by distance upon speed. Right? So what we are looking for is the time for this journey, which is x by 2s. Let's now if you look at these two equations, what is happening here is that x by s is common in both of them. So let's call x by s as delta. So from the first equation you have delta is equal to 2t. What I've done is x by s I have taken as delta. So x by s, if I replace x by s by delta here, this will become delta by 2 is equal to t, so delta is equal to 2t. And in this case, if I use delta for x by s again, I'll get 3 delta is equal to t plus 1. So now you have a typical two equation, two unknown situation. You are supposed to find delta. To do that, you can replace t as delta by 2 from this equation into this equation, and you'll get 3 delta is equal to delta by 2 plus 1. So 2.5 delta is equal to 1 hour. So delta is equal to 1 by 2.5. And once you have that, which is 1 by 2.5 is 4 by 10 hours. This is the value of delta, which is 24 minutes. Because 1/10 of an hour is 6 minutes. So 4 by 10 of an hour will be 24 minutes. This is the value of delta. But we did not want x by s, we wanted x by 2s. So we need delta by 2. So don't forget to divide this 24 further by 2 again to get 12 as the answer. So this is the classic case that the CAT is doing these days, and you need to be aware of how you need to handle this stuff. And what the CAT is doing is it's leaving you with more unknowns than equations, and this is happening all the time. And you need to understand how to handle such situations, because and this case, for example, you had 3 unknowns, 2 equations, but the way they gave you exit route out of that was they were not asking you for the values of the individual unknowns. So if you look at this equation or the second equation that we got here, in both these equations, x, s and t, there are 3 unknowns. But the redeeming factor in this question, 3 unknowns, 2 equations, you can't solve for the individual unknowns. But the redeeming factor of this question was that you needed a value of x by 2s. This is the value that you were targeting here. Right? So that was the redeeming factor in this question. So let me just take you through this again. You might have some confusions with respect to solving this. So let me just wipe out the solving portion, and let's just do it again so that you are comfortable with this solution. So the starting point of this question started from, maybe I'll just rub off the whole screen and redo it for you. So what the question said, what the question was saying was that you have a journey between A to B. Just taking you through this again. You have a journey from between A to B with a point P in between. Such that this distance, if I take this distance as x, then this distance is 3x. And there are 2 cars, one car is going from this side, car 1, another car is going from this side, car 2. Car 1 is traveling at a speed of 2s and car 2 is traveling at a speed of s on this journey, and car 1 takes t hours to reach P and car 2 takes t plus 1 hours to reach P. So the starting point of the equations in this question were based on this understanding that you have x by 2s is equal to t, and 3x by s is equal to t plus 1, because distance by speed is time. And the target, so this is two equations, three unknowns. You are in a two equation, three unknown situation. And the target value for you is not x, s or t. You need to recognize that since you want the value of t specifically, your focus is to find x by 2s. And that's where the opportunity comes to take x by s as delta and solve for two unknowns. Instead of solving for three unknowns, x, s and t, you're solving for two unknowns, delta and t. And once you're in the two unknown, two equation situation, the problem gets solved pretty easily. Right? So I'll do one last question for this session, and I hope you can go ahead from here. After that, the next steps were delta by 2 is equal to t, and 3 delta is equal to t plus 1, and then it was just a matter of substituting t from one equation to the other to find the value of delta. And once you got the value of delta, your target was x by 2s. So your target was to find delta by 2. So once you got delta from these two equations, you could find delta by 2, which turned out to be the answer. Right? Let's do one more question for this lesson. And this question is the one you see on your screen next. So trader sells 10 liters of a mixture of paints A and B, where the amount of B in the mixture does not exceed that of A. So let's make sense of that information. And this is an important aspect of all CAT problem solving, and in fact all aptitude problem solving, that whenever you get fresh information, you should make sense of that information before you move on. So trader is selling 10 liters of a mixture which contains A and B, and amount of B does not exceed that of A. So B is less than or equal to 5, and A is greater than or equal to 5. This is the meaning of that. The cost of paint A per liter is rupees 8 more than cost that of B. So B का cost अगर C है, तो A's cost is C plus 8. That's the meaning of this. If the trader sells this entire mixture for rupees 264 and makes a profit of 10%, then what is the maximum possible cost of paint B in rupees per liter? So we are trying to find the maximum possible value of C. If he is selling at 264 and making a 10% profit, this basically means that his cost price into 1.1 is 264, and that means his cost price is 240. And we are looking at 10 liters for 240, which means that the average cost of A and B 10 of the 10 liter mixture is 24 rupees per liter. Now from here you have to think in terms of allegation in this question, and the way to think is this, that if you take C here and C plus 8 here, and the average has to be 24. The average price per liter has to be 24. Then let's go back to the question. Highest possible cost of pane B. Now, what is the cost of pane B will depend on the ratio of how much this is how much B you're using, and this is how much A you're using. The cost of A is 8 rupees more than the cost of B. So how much B, I mean, you can use, or what is the highest value of B you can use, will depend on the ratio. So one end of the ratio is the limiting ratio of 1:1, 5 liters each. At that situation, this turns out to be 20 and this turns out to be 28 because 24 has to be the midpoint in such a case. But if you start skewing the mixture, the ratio more uh, towards using less of B and using more of A, if you increase this, if you increase A more quantity of A and less quantity of B, for example, suppose you use 6 liters of A and 4 liters of B, which means you're using them in the 3:2 ratio, you can clearly see that the price of B will start going down below 20. Reason is that this 2:3 and this distance between C and C plus 8 will always be 8. That distance is always 8. And the allegation structure is that this 3 corresponds to this distance, this 2 corresponds to this distance, and the total sum of the two, 5, corresponds to the 8. So if 5 corresponds to 8, 1 will correspond to 1.6. If you drop 24 by 1.6 3 times, you'll get to 19.2. So you can clearly see that if you're shifting the ratio from 1:1 between B and A to less than 1 is to more than 1 here, or ratio greater than 1 in favor of A, then the amount of B that you are putting on, the price of B that you have is lower than 20. And hence the maximum price will happen when it's a 1:1 ratio, and that's why option C is the right answer. Right, so I hope you enjoyed these questions. I'll be back in 5 minutes with the next lesson on this. And it's been good talking to all of you. Thank you so much for watching. Bye-bye.